I want to show you how to find the line tangent to the graph of a function at a point. So now that we know what a derivative is, so say that we've got a function y equals f of x. So for example, you could choose y equals f of x equals x squared. And let's choose a point. Let's choose a equals 1. And we've calculated, by the definition, we've calculated the derivative of x squared at the point a equals 1. And we found out that the derivative at that point was equal to 2. We did that directly from the definition. And so what this means is that the slope of the line that's tangent to the graph of y equals x squared has to be equal to 2. So there's two things that we need to actually find a formula for that tangent line, and one of them is the slope. We've got it, great. And the other thing that we need is a point that the line goes through. Well, if you're given a point x equals a, in this case a equals 1, well, that's your x value, and you can find the y value by just plugging in. So if the x value is a, the y value is going to be f of a, and so here's a point that the line has to go through, and the derivative f prime of a, that's going to be the slope. So whenever you've got a point and a slope, you can use that point slope formula to figure out the line that goes through y equals f of x with that slope, with that point. And so here's that formula, just writing it down directly. So I can take y equals the slope, that's f prime of a, times x minus a plus f of a. So I've written this down in a format that you may not be super familiar with, but it's really good for studying calculus. Later on when we do Taylor polynomials, you'll see that this is a great way to express that tangent line. Why do I like to write it this way? Because what if I plug in x equals a, then this becomes 0, and I'm just left with f of a. So this clearly has the property that this point lies on that graph, because plugging in a, the y value is f of a. And one thing you can keep in your mind, the thing that multiplies this x term, that's going to be your slope. So your slope really is f prime of a. So in this example with f of x equals x squared and a equals 1, and let me draw that for you. Good schematic representation of x squared. And let's say that's a equals 1. And let's say there's the point a, f of a, and that's going to be f of a is 1 squared, so it's just 1, 1. And we want to look at the line tangent to this. So just plugging into that formula, here's what we're going to get. Let's take y equals 2, calculated the derivative to find that, times x minus 1 plus f of a. It's equal to 1. And you can expand this out if you want. Give you y equals 2 times x minus 2 plus 1. That's going to be 2 times x minus 1. OK. And if we draw that tangent line, it's a line that goes through the point 1, 1. And has slope equal to 2. So slope equals to 1 would split this right at a 45-degree angle. Slope equals to 2 is a little bit more vertical this way. So it'll look like something like that on the graph. And you don't have to just check my handwriting. You can go straight to Desmos or Wolfram Alpha. You can plug in this equation. You can plug in y equals x squared. It'll draw them both on the same graph. And you can really see that tangent line for yourself superimposed. So you're thinking of tangent line as the line that goes to the same point on the graph, but it's the unique line whose y values are closest to the y values of your original function. So that's why we use derivatives. That's like why we like to find tangent lines.